Okay, welcome back, folks. Trigonometry, angles and ratios, lesson 4, solving simple trigonometric equations. So we are going to use our knowledge of the cast rule. Remember that, or add sugar to coffee, whichever rule you're using. We're going to use that knowledge as well as the information that we know on how to solve angles to determine where possible reference and or rotation angles could be. Okay. This is going to apply, most of the time it's going to apply for values where theta is between 0 and 360. But sometimes, every now and then, they like to throw in the oddball question, which limits this. So between using this and our positive or negative values of whatever the angles are after the trig ratio has been determined, and our cast rule is going to help us to determine where these angles fall. Okay, so here I'll just read through these instructions here. So solving trigonometric equations with the domain of 0 to 360 degrees, so within one full circle. So within one full circle, you're always going to find two possible angles, two possible rotation angles that give you the same values for sine, cosine, or tangent, depending on the trig ratio you're given. Okay, so know that if it's between 0 and 360, there should be two possible answers, and you'll see that as we work through. Okay. So it says we can use the concepts of reference angles and sines of the trigonometric ratios to solve equations of the form sine theta equals A, or cosine theta equals A, or tangent theta equals A, where theta is between 0 and 360. And the following procedure, basically these three steps need to get followed. Okay? So as an example, it's saying, well, here's a situation. If sine theta is 0.5, where are the two possible angles between 0 and 360? And these are the steps. And we're going to go through these steps specifically with example 1, but it's just introducing it here. Okay. So it says, first, determine the quadrants where the angle will be looking at the sine of the ratio. Determine the quadrants the angle will be in by looking at the sine of the ratio. So here, I know that this is positive. What quadrants, oh, that's a wrong pen, that's not going to say. What quadrants are the values for sine positive? Quadrant 1 and quadrant 2. So we don't have to worry about quadrant 3 or quadrant 4 because the sign for those values would be negative. So we know we're going to have some kind of angle in quadrant 1 and some kind of angle in quadrant 2. And we just have to determine what those are. Okay. Step 2, determine the reference angle, which will always be between 0 and 90 degrees, and draw a rough sketch in the appropriate quadrant. To determine the reference angle, we use the inverse function, or second function sine or cosine or tangent, the inverse function, to find that angle. And we do that of the absolute value of the given quantity. So that means that always this positive value. If this were a negative value, we'd still stick in the positive value. Okay, because that's going to cause a little bit of grief. Okay, so we always use the absolute value. And then number 3, determine the rotation angle using the reference angle in that quadrant. Okay, so once we have that reference angle, we can determine the rotation angle. Notice the big stop sign here. Always check the given domain to determine which quadrants are valid in the calculation. Sometimes the domain is restricted, like I'd already mentioned. So maybe it's just a half circle, 0 to 180, or maybe it's just a quadrant, 90 to 180, or it could be any combination of anything. So you have to be really careful on what you're looking at. Okay. Example 1, use the procedure above to solve sine theta is equal to 0.5, where theta is equal to 0. Theta is going to be between 0 and 360 degrees. So we first start out by saying, well, if sine theta is positive, I'm going to change my pen here. If sine theta is positive, then I know, using my cast rule, that it cannot be in quadrant 4 and it cannot be in quadrant 3. So I know that I'm going to have an angle somewhere in quadrant 2 and in quadrant 1. That's step 1. So I know I'm looking for two angles, quadrant 1 and quadrant 2. Now I use my knowledge of trig ratios. So if I know that sine theta is equal to 0.5, I know in order to calculate theta, I do the inverse function of sine of the absolute value of 0.5, which is already positive, so it's 0.5. And that's going to give me theta is equal to 30 degrees. This is my reference angle. Okay, this is my reference angle. Now I use this in combination with this idea of my two quadrants to determine what my two rotation angles are. So let's do it step by step. In quadrant 1, it's going to look something like this. I'm going to have some kind of angle that has a reference angle of 30 degrees. What's my rotation angle? 30 degrees, because the reference angle and rotation angle in quadrant 1 are the same. But in quadrant 2, you'll see, here's quadrant 2, there's my angle, there's my reference angle of 30 degrees. What is my rotation angle? Okay, so to determine that, I'm going to go 180 minus 30 degrees. That's going to give me 150 degrees. 150 degrees. That's my rotation angle in quadrant 2. So there's my two possible answers. Okay? Because the domain was 0 to 360. Because this specified 0 to 360. Okay, so let's do a few more just to get used to doing that process. Example 2. Find the measure of x to the nearest degree where x is between 0 and 360. So we know we're looking for two answers for each of these questions. And of course, we have three different scenarios, each with the same value. Well, the sine and cosine are the same, tangent's different. But, okay. Oops. There we go. So step 1, I know and I can see that the sine value is negative. In what quadrants are my sine values? Oops, C-A-S-T. Almost spelled cats. Cast. All are positive here. It can't be in quadrant 1. Sine is positive here in quadrant 2. So I'm looking for two angles, one in quadrant 3 and one in quadrant 4. That's step 1. Step 2, determine the reference angle. So to determine the reference angle, I go sine of x is equal to 0.8090. That's supposed to be an 8. Remember, we're finding it for the absolute value, the positive value, which means that's x is equal to the inverse function of sine of 0.8090, which is equal to, I have 54 degrees. 54 degrees. That means my reference angle is 54 degrees. So now I think, well, what's it going to look like? Oh, I'm running out of room. What's it going to look like in quadrant 3? In quadrant 3, there's my 54 degrees. What? It looks like a 3 now. There's my 54 degrees. What is my rotation angle to there? That's going to be 180 plus 54, which is equal to 234. Change my pen. It's clearly too fat. That's in quadrant 3. Now I do the same process for quadrant 4 because we can have that same value in quadrant 4. So in quadrant 4, my reference angle is going to look like this of 54 degrees. I want this rotation angle, which is going to be 360 minus 54, which is equal to 306. So there's your two possible answers. And you could test that on your calculator. You could simply go sine of 234 and sine of 306 and see that they're both going to work out to negative 0.8090. Okay, it's not a difficult process, but it's very specific in the steps that you have to follow. Okay, example B, cosine x is equal to negative 0.8090. Again, what quadrants is cosine? I don't know why I stuck with red. What quadrants is cosine negative in? C, A, CAST. Well, it's not here when they're all positive. It's not in cosine positive, so it's in quadrant 2 and quadrant 3. That's step 1. Step 2, figure out what x actually is. If cosine x is equal to 0.8090, remember it's the absolute value. So as long as it's positive, you'll be fine. X is equal to the cosine minus 1 of 0.8090. X is equal to, I got 36 degrees. So you should check just to make sure. You know what? Just because I'm going to check just to make sure too. Second function cosine 0.8090. I got 36 degrees. Yeah. So now I know in quadrant 2, this is what it's going to look like. There's my reference angle of 36, but I want the rotation angle here, which is going to be 180 minus 36, which is equal to 144. There's one answer, 144. And then in quadrant 3, I do the same thing. This is what it's going to look like. There's my reference angle of 36 degrees. This is going to be 180 plus 36, which is equal to 216 degrees. There's your 2 possible answers. This would be a perfect time to pause the video and attempt number C or question C on your own. Tangent x is equal to negative 2.4586. You should be able to determine what 2 angles x could possibly be to give you that value. Pause the video, take a shot, or if not, just continue to follow along. So I know that in tangent x is going to be negative in which quadrants? C, A, S, T. Can't be here, they're all positive. Can't be here, tangent's positive. So in quadrants 2 and 4. Now to determine the reference angle. Tangent x is equal to, of the absolute value, 24586. So x is equal to the inverse function of tangent of 2.4586. X is equal to 68 degrees. And again, just a quick double check. Second function tangent 2.4586, 67.88, which is 68 degrees. So my reference angle is 68 degrees. So now I look in quadrant 2. Well, if my reference angle is 60, ooh, that's an ugly line. If my reference angle, that's uglier too. If my reference angle is 68 degrees, what is this rotation angle? That's going to be 180 minus 68, which is equal to 112. And I do the same in quadrant 3. No, sorry, not quadrant 3, quadrant 4. In quadrant 4, my reference angle is still 68 degrees, but this is going to be 360. So I want the rotation angle. I want the rotation angle from here to there. So that's going to be 360. Take away 68, which is equal to 292 degrees. Like I said, it's not super difficult. It's just very stepwise, and you really have to pay attention to the steps that you're doing. Okay. Over the page, example number 3. Solve the following equation if theta is between 0 and 360 degrees, where sine is equal to 1. Sine is equal to 1. Step 1. Step 1. It's kind of positive. 1 is positive. 1 is positive, so I check this, C-A-S-T. Sorry, I'm stuck on red. Positive is there in 1 and 2, not in 3, not in 4. So we're looking for quadrants 1 and quadrants 2. I determine what my reference angle is. If sine of theta is equal to 1, then theta is equal to the inverse function of sine of 1, which is equal to 90 degrees. I want to say 90 degrees. Double check. Second function sine 1, 90 degrees. So my reference angle is 90 degrees. Okay? This is a tricky question. So now if I look at quadrant 1, where is my reference angle of 90 degrees? My reference angle of 90 degrees is right here, 90 degrees. What's my rotation angle? 90 degrees. Okay. In quadrant 2, this is what it looks like. Where's my reference angle of 90 degrees? Well, my reference angle of 90 degrees would go back this way to here, 90 degrees. Well, what's that rotation? 180 minus 90, which is equal to 90 degrees. So both answers are exactly the same, and I would only really need to state that once. So 90 degrees would be a final answer right here. Okay. It's a weird one that falls on one of the axes. Those are very tricky. Okay. Question B, cosine theta is equal to 0. Cosine theta is equal to 0. Oh, what is 0? 0 is not positive or negative. Well, then let's look at our cast rule. I'm going to do this back in purple now. Let's look at our cast rule. Well, if theta, if 0 is not positive or negative, then really it could possibly occur anywhere in a circle. So we really have to determine what it is in all 4 quadrants. So then I determine my reference angle. If cosine theta is equal to 90 degrees, then theta is equal to, sorry, not 90, 0. If this is equal to 0, then cosine, whoops, that's a razor. Cosine minus 1 of 0 is equal to, again, 90 degrees. Just a quick double check. Second function cosine 0 is 90 degrees. Now I look in quadrant 1. In quadrant 1, my reference angle of 90 degrees would be right here. My rotation angle, 90 degrees. Because that's really what these questions are asking for, is what the rotation angle is. And you have to get there via the reference angle. In quadrant 2, my reference angle of 90 degrees, back this way, would be right here. My rotation angle, again, 90 degrees. In quadrant 3, my reference angle of 90 degrees would be right here. There's my reference angle of 90 degrees. What's my rotation angle? 270. And then in quadrant 4, where's my reference angle of 90 degrees? Would be right here. My rotation angle, oops, I put that in the bad spot. My rotation angle would be 270. So really, two answers are the same, and the other 2 answers are the same. So I would just say 90 and 270. I only really need to state it once. Okay, but those ones that fall on the axes, those are the tricky ones. You got to be a bit careful. Not a bit careful, a lot careful. Example 4, solve the equation 3 tan theta plus 1 is equal to 4, where theta is between 0 and 180 degrees. So here's our first question in which we're restricted to the first half circle, the first 2 quadrants. Okay, but we've never really seen this, have we? We can simplify this statement. Oops, I'm going to go to purple again. No, I'm going to go to blue. 3 tan theta plus 1 is equal to 4. We really need this tan theta by itself. So I need to subtract 1, both sides. That gives me 3 tan theta is equal to 3. And then I need to divide by 3, both sides. That gives me these will cancel. Tan theta is equal to 1. Okay, so now I know that tan theta is positive. What are my possible quadrants? C, A, S, T. Well, tangent's positive there. It's negative here. And it's negative here. But again, we are only concerned with the first 180 degrees. So we're not even concerned with quadrant, whoops, that's an eraser, with quadrant 3. So we're only looking for quadrant 1. So now I find the inverse function of tangent. So I go theta is equal to tangent minus 1 of 1, which is equal to 45 degrees. And I think, well, in quadrant 1, if my reference angle is 45 degrees, my rotation angle is 45 degrees. Okay. Now, the only way to make these even trickier is to play around with this domain of 0 to 360 degrees, which is one full circle. Maybe it's going to be only the first half circle like we saw in the previous example. Maybe this is going to go from 0 to 720, which should be 2 full circles, which means there should be 4 possible answers. Or maybe it goes negative. Maybe it goes from 0 to or negative 360 to 0. Well, then you're going to have negative reference angle or negative rotation angles. Okay, so that's the only thing that changes. All the other steps are the same. And then you use the information that we know about our coterminal angles to determine where the rotation angles will fall. Let's look at example number 5 in purple. Solve the equation square root 3 tangent theta plus 1 is equal to 0, where theta is between 0 and 720. So this means 2 full circles. And if in one circle we can get 2 answers, in 2 full circles, we should be able to get 4 possible answers. Okay? So again, we have to do what we did before, is we have to get tan theta by itself. We have to get tan theta by itself before we can determine what quadrant these reference angles are going to fall in. So I'm going to subtract 1, that's going to give me square root 3 tan theta is equal to negative 1. I'm going to divide by square root 3, It's going to give me tan theta is equal to negative 1 over square root 3. Now, we're not trying to find a final answer here. We're trying to find an actual number. So we don't have to worry about rationalizing the denominator. We can just plunk this straight into our calculator and have the calculator do the work for us. Okay, but this does tell us, though, that tangent theta is negative. So where is tangent theta negative? C-A-S-T, negative, not here and not here. So it's in quadrants 2 and quadrants 4. So and that's in one rotation. And in our second rotation, it would again be in quadrants 2 and quadrant 4, or 4, 5, 6, and 8 if you want to count, continually count. Okay. What's the value of our reference angle? Tangent theta is equal to tangent minus 1 of negative 1 of the absolute value, square root 3, of negative 1 over square root 3 is positive 1 over square root 3. Putting that into your calculator on, just to double check, second function tangent bracket 1 divided by square root 3 in bracket is 30 degrees. 30 degrees is my reference angle. Okay, so now in quadrant 1, we don't worry about it. In quadrant 2, I have a reference angle of 30 degrees, which means my rotation angle is going to be 150 degrees. And in quadrant 4, I'll do this in blue. Quadrant 4, I have a reference angle of 30 degrees. Oops. Reference angle of 30 degrees. My rotation angle, through to here is going to be 330 degrees. Whoops, 30 degrees. That's in one full circle. In another full circle, though, you would take this, because it's another full circle to get there, and you would add 360. So that's going to be 510. 150 and 510. And then here, of course, you're going to add 360 as well. That's going to give you 690 degrees. So there's your 4 possible answers. Okay. These ones where you're outside the realm of the full single full circle get a little bit tricky. Okay, but you just use your rules of coterminal angles. Example number 6. To the nearest whole number, solve this equation. Cosine x is negative 0.82, where x is between negative 360 and 0. Negative 360 and 0. So that's a full circle backwards. So our rotation angles are going to be negative. So negative cosine x is negative 0.82. So where is cosine negative? Back to purple, using my cast rule. Cosine is not negative here, and it's not negative here. So it's in quadrants 2 and quadrants 3. Cosine x is equal to negative 0.82. So to find x, I'm going to do the inverse function of cosine, but of the absolute value, 0.82. That's going to give me a reference angle just to double check. I think I wrote down 35. Second function cosine 0.82 is 35 degrees. So in quadrant 2, in quadrant 2, I have a 35 degree here. And in quadrant 3, I have a 35 degree here. 35. And remember, we're going backwards because it's negative 360. So my rotation angle goes this way, which is going to be 90, 180 plus 35, 180 plus 35, which is equal to 215, but negative because it's going clockwise. And in quadrant 3, here's my rotation angle. Okay, rotation angle is going to be 180 minus 35, 145, but negative because it's going backwards. Okay, that brings us to the end of lesson 4. Paying attention to Stellantis or the notes in the calendar to figure out what questions are going to be assigned. And we will see you next time.